Today, 50 years after introducing the black hole, we are witnessing the clear evidence on the energy extraction from a Kerr black hole by Blackholic Quanta in GRBs and galactic nuclei. I'm very happy to present this result at the 43 COSPAR Scientific Assembly. But let's trace back the history, how this great result finally was reached. On December 1962, a rocket was launched from the White Sand missile range in Mexico by Riccardo Giacconi, Herbert Gursky, Frank Paolini, and Bruno Rossi, on board an X-ray detector, looking for the first time at the universe up over the absorption of the atmosphere. A source was evidence, a source of X-ray from outside the solar system. This was the starting point, really, of relativistic astrophysics. Few months later, Martin Schmidt found inside the radio source 273 the presence of a star-like object with a large redshift Z0158. 50 years of cosmic mystery started then. The source of this object, the source of energy, tremendous energy, we have now finally the first evidence that it comes from Blackholic Quanta emitted from a Kerr Black Hole. But I think the third very important discovery came in 1968 by the discovery of Tony Hewish and Jocelyn Bell of the Crab Nebula Pulsar. This object has been of tremendous importance, not only for the beauty of the scientific data, but especially because it was possible for the first time to identify the source of this energy in a cosmic object, an object inside the galaxy formed by the gravitational collapse of a supernova and leading to a neutron star formed of packed neutrons, protons, and electrons, as emphasized by Bade and Zwicky and Oppenheimer and Volkov. This was a tremendous thrill all over the planet. And I was just arriving in Princeton in 1971, working with John Archibald Wheeler and his group, and we start immediately to go on the new field of these cosmic energy sources. It was John Wheeler, exactly 50 years ago, that decided to publish a paper introducing the black hole. The key idea was to find an object, a new object, physical object, characterized by mass, spin, angular momentum, and also the irreducible mass. And the object was carved in the geometry of the Kerr metric. And this is a beautiful picture conceived at the time by an artist in New York for the cover of Physics Today. The mass formula, that has been the key, followed soon after. It was Dimitrios Christodoulou, at the age of 19 at the time, working with me in Princeton, that identified the first mass formula of a Kerr Black Hole. And then soon after, this was September 17, 1970, soon after, March 1st, 71, the paper of Christodoulou and myself on the Kerr-Newman metering, and also a few days later, March 1st, March 11, the work of Hawking in fifth love letter, reaching the same general formula. Therefore, it has been a great pleasure after the visit in Stockholm of Roy Kerr to go to Cambridge and visit in a memorable 3 days meeting Stephen Hawking, and completing the visit with this dinner on June 20, 2017, Roy Kerr with his wife, myself, and Stephen. A memorable result. But let's go to the path which led to verify that mass formula. The path was started by a military search for bomb explosion on the surface of the Earth and the Moon by the Vela satellites. Indeed, this satellite saw X-ray emission coming from possibly from nuclear bomb explosion. The result, however, was too new. It was no evidence for nuclear bomb correlation. There was a hint that there was something fundamental for relativistic astrophysics. And this is the reason why Herb and myself called a meeting in San Francisco in 1974. The story had to wait from 1974 to 1996, for 22 years, to find a first answer to the nature of this gamma ray burst. The secret was unveiled by this Italo-Dutch satellite, Beppo Sax, which came out of the mind and of Beppo Sax, Beppo Occhialini. And it was thanks to this instrument that the traditional gamma ray emission of the Vela satellite were associated to an X-ray emission with very good spatial resolution. And it was then possible for the first time in that position to point radio telescope, to point other satellite, but especially optical telescope. And was very fortunate that the largest telescope in the visible, the VLT done in Chile by Riccardo Giacconi, and the detector of Mauna Kea were ready to catch the few optical photons and identify the tremendous redshift of the sources and therefore their extremely large distance. Therefore, they were like atomic bomb on the surface of the Earth or on the Moon. But since they were at 10, 15 billion light years away, their energy was a tremendous 10 to the 54 Earth per second. What it means 10 to the 54 Earth per second? It means just the energy, if we take the energy of the sun 10 to the 33, we multiply by the number of stars in the galaxy 10 to the 12, 10 to the 45, we need still 10 to the 9 to reach 10 to the 54. 10 to the 9 are the number of galaxies in our light past cone. Therefore, we were seeing an object which in a few seconds was really characterizing the same energy of the entire star of the universe. This was dramatic, very dramatic, much more than just the first black hole identified in binary X-ray sources by the data of Riccardo Giacconi from Uhuru. We were in front of a completely new domain. The gamma ray burst had an energy much bigger than the energy of a nuclear bomb explosion, 10 to the 30 times bigger. And if we look at the flux of energy with respect to particle acceleration on the Earth, we find energy 10 to the 40 times, flux 10 to the 40 times are larger. And not only emission in GeV, also in TeV, also ultra energy cosmic rays, sources in GRB of the order of 10 to the time bigger than the energy in the earthbound accelerator. It's a continuation of the particle physics at CERN, a continuation of this physics to enormously much larger energy, and ready to discover completely new physics. But let's look at this new physics. The first possibility to identify a source for the short GRB, which are of the order of a second, or less than a second, was due to the work of Pashinsky, who postulated that short GRB originated from merging of two neutron stars, very similar to the neutron star generated in the Kerr Pulsar, but in binary system, and merging due to gravitational radiation. The long model for GRB, more energetic, lasting longer, was proposed by Rees, Metzaros, Woosley, and others. And the idea was that this long GRB originated from a rotating black hole of Kerr and emitting a very strong jet of moving at ultra-relativistic velocity. This narrow point of view was really changed dramatically in the last 10 years, when since we understood that long GRB, not only the short one, originate in binary system, but a binary system composed of CO star, of neutron star, of white dwarf. And let's look at what we think a long GRB originates from. They originate from the late evolution of binary X-ray sources, the one we study in SENX3, in Cygnus X1 with Riccardo Giacconi. But out of the CO core and the companion neutron star, suddenly the CO core gravitational collapse create a new neutron star, and the process of accretion, both on the new neutron star and on the companion neutron star, occurs. Here in the middle, you see this simulation we have done, thanks to the great help which we have received from Chris Fryer and the Los Alamos laboratory. There you see the shell of the supernova emission accreting on the new neutron star and generating the X-ray afterglow, or accreting on the companion neutron star. And if the binary system of the CO core and the companion neutron star companion is short enough, the order of 5 minutes, then the gravitational collapse of this companion neutron star occurs and you form a black hole. And here, the new physics of black hole start. But let's look at the inner engine of this object. But before even looking at the new at the inner engine, let's look at the fantastic instrument that have allowed to make the observation to motivate a detailed theoretical model. The first big result following Beppo Sax has been certainly the Fermi Gamma Ray Telescope, with the two instruments and the high energy instrument, the LAT, which was developed thanks to the experience developed in Italy on the detector by the ENFN of the calorimeters. And at the same time, the second contribution, equally important, were the VLT telescope created for ESO by Riccardo Giacconi in Chile. And they allowed to detail observation in the spectral feature, which have characterized GRB. And then again, another mission, very fortunate, developing the X-ray part of the observation, which were done in the wide field X-ray in Beppo Sax, but a much larger scale, the Niels Gerald Swift Observatory. But what has happened in the recent year is that to this great family of observatories, another set of instruments was introduced from the Earth by the magic gamma ray Cherenkov Observatory, and especially an important observation from Observatory of La Palma in the Canary Islands allowed to see the TEV radiation emitted in GRB 190114C. And then even to this family of multi-messenger and multi-wavelength, lately there has been a very successful mission from China, the Hard X-ray Modular Telescope Detector, which has joined the group. But let's look now to the physics. The key of the GRB is a black hole, but not isolated like we have been thinking in the past, but a black hole which lives together with a very strong magnetic field of the order of 10 to the 10, 10 to the 11 Gauss, which is practically connected to the spin and the axis of spin of the Kerr Black Hole. I have not the time to go into detail, but this gives you a little bit the general framework of this solution, which we have recently studied. And we have seen for the first time the manifestation of the Blackholic energy quanta. What we see in this source, for example, in 130427A, is that the emission in the JEV is not continuous, but is emitted in quanta. Quanta of the order of 10 to the every 10 minus 5 seconds. And each quantum is 4.7 10 to the 36 R. but the energy of the particle is up to 10 to the 18 electron volt, and the emission is of the order of 10 to the 41 ergs. This is the inner machine. And this same solution scale for active galactic nuclei, where, like M87, in which the emission occurs not every 10⁻⁵ seconds, but every half a day, and with energy even bigger for the cosmic ray, or up to 10 to the 19, 10 to the 20, and again, with a quantum of the order of 10 to the 47 ergs, and energy of the order of 10 to 43 erg per second. Recently, we have done all the details of a source, GRB 180720b. Here we represent the spectra in X-ray, in the JEV, and we see the different episodes, the explosion of the supernova, the UPA, the prompt emission, the cavity, the hard X-ray. But we understand of each one of these, the theory is represented by the continuous on the dotted field, and the data from the red by Fermi-LAT and Fermi-GBM. And this first bump is the supernova rise, and then the UPE, the ultra-relativistic prompt emission. Similarly, the X-ray afterglow is just due to the accretion of the supernova into the rotating neutron star. And we can determine the rotation of the neutron star in 1.2 milliseconds and seeing the slowing down. But it's the entire picture of the system which is beautiful. In particular, we have this prompt radiation, 1, 2, 3, 4, 5, which represent the most energetic part in the MEV, and then we have the red part in the JEV, and then we have the black part in the X-ray. There are three components, completely different. The one related to the supernova rise, the one with the afterglow of JEV originating from the rotation of the black hole, and the X-ray emission originating from the neutron star X-ray. And what is beautiful is that during this afterglow here, you see suddenly a glitch in the neutron star, glitch which were observed in Pulsar, but here in a very early born Pulsar, in the first 10 to the 3 seconds of the Pulsar originating the X-ray afterglow. But much more has to be understood. Liang Li has found that if you look at the detailed analysis of the MEV radiation, you find a self-similarity coming in, and which testify that is the structure all the way down to 10⁻17 seconds. It's a fractal present, a self-similarity, and this is our work. And the model which we have made allow us to see in all detail this jetted emission of the JEV. The jetted emission of the JEV, which is in two cones of approximately 60 degrees, which we are just completely in this house. If we look, therefore, at the GRB, we see emission every 10⁻⁵ seconds. But if we look at the large black hole, like an M87, the emission occurs, the physics is the same, but it scales from 10⁻⁵ seconds to half an hour. Therefore, in general conclusion, is we see today 380 of this binary system composed of a CO core and companion neutron star, which we call binary-driven hypernova. To sum up, in addition to the first event, which is characterized by the supernova and by the accretion of the supernova ejecta into the new neutron star generated in supernova, we see one of the first components, the X-ray emission, with a typical power law. And similarly, we see a JEV emission from the accretion of the supernova into the companion neutron star. And everything is dictated by the inner engine. Looking at the future, we have just an immense amount of new physics which comes about. A new physics which will be looked by the ESA satellite, Theseus, and which generalize the satellite which in X-ray SWIFT, and much we expect from this, but also we are dreaming for a new detector, a new satellite, which could use this technique developed in Italy with international strong collaboration for creating the calorimeter, first of Agile in the very high energy, the same calorimeter used by Dampe, and again a Fermi-Lat calorimeter developed in Fermi-Lat. What we need to follow is with a big mission, similar to Theseus in the JEV region, in order to continue this tradition and especially to scrutinize the new physics, completely new physics, in the very short period. This work was possible thanks to the collaboration of so many collaborators in Europe, in the US, and in China. And of course, it was made possible following the idea of Albert Einstein at the very ground of general relativity and relativistic astrophysics and black holes. But I would like to close with a picture I took one day of Paul-André-Marie Dirac. Dirac one day said that the new cosmology will probably turn out to be philosophically even more revolutionary than relativity or quantum theory. I fully agree with him, and we are ready to have the challenge to do the observation and reach the understanding of this domain of science.